Hello, I'm not here. As you can see, there's hopefully a substitute teacher showing you this video. If not, you're all behaving very well for not having anybody supervise you. So what I would like to talk about today before we watch the videos for the classwork is the definition of a perpendicular line. Perpendicular means lines that intersect at a 90-degree angle. This is a protractor. This is a tool for measuring angles of lines. And the bottom line here and these angles out here are how you measure it. So if I put my pencil right here, you can see that it's actually pointing to the 90-degree angle, and it looks like a 90-degree angle. It is. That's how you measure it. So I've drawn a couple lines on the back here with a coordinate plane and talk about some stuff here. So I've drawn an x and y axis, which you know intersect at a 90-degree angle, and I can prove that by doing that. Look, it lines up perfectly. Now, I'm going to measure these two lines and see if they intersect at a right angle, and it kind of looks like they do if I turn it like that, but let's prove it with the protractor. So I can pick any dot here and line it up, and as you can see, that and that line up perfectly 90 degrees. It is a right angle. Now I've already shown you that the rise and run of this line, positive 2, run 1, up 2, right 1, that's a slope of 2. And I've actually done that over here as well. If you go down 1 and right 2, down 1, right 2, that's a slope of negative 1/2. Now, there's something we're talking about for the perpendicular lines that matters for today's lesson, and that's the slopes of perpendicular lines. Perpendicular lines have slopes that are, first of all, one's going downhill, one's going uphill, so they have to be opposites. But there's a little more to it than that, and maybe this next example will show that. So, I have two lines here that intersect, and we'll see if it intersects at a right angle down here. And ignore these two little guys here. I made a mistake, so I'm pretending like they're not there. So let's measure this and see if these two lines intersect at a 90-degree angle. And it does. Now let's do the slopes of these two lines. So again, these lines go through the origin. It doesn't necessarily have to go through the origin. It could be anywhere on the graph, but I just happen to do this. So you rise 4 and run 1. So this guy has a slope of up 4 and right 1, which is just 4. Now this slope goes down 1 and right 4, or down 2 and right 8. Either way, if you go down 1 and right 4, it's a negative 1/4 slope. So maybe at this point you can see a pattern about the slopes of perpendicular lines. We proved that they intersect at a 90-degree angle, but there's a relationship between the slopes of lines that are perpendicular. First of all, one of them is positive, one of them is negative. That's true here too. But there's more. And what do you call that when you flip a fraction? Well, they're called reciprocals. So perpendicular lines, and I would like you to write this at some point at the end of this video, they have slopes that are opposites, that are 1, opposites, and 2, reciprocals of each other. Slopes that are opposite reciprocals. So an example of this, oh, and by the way, the symbol for perpendicular lines is an upside down T. So that means perpendicular right there, and I'm going to draw an arrow to that. That sign means perpendicular. So perpendicular slopes. And you know that the slope is the letter M. So if I said the original slope was 3, the opposite reciprocal of 3 would be negative 1/3. So again, if I gave you a slope of 3, the perpendicular slope would be negative 1/3. Let me give you another example. What if I said the slope was negative 3/8? Well, what would be the perpendicular slope? Well, the opposite of negative is positive, and the reciprocal is just flip it over, so it would be 8/3. Okay? So again, I'll put this up at the end of the video so you can watch it, write this all down. Last example I want to do is this one because it seems to trick kids for some reason. I'm not even going to draw the line. Up 1, right 1, up 1, right 1, up 1, right 1. That slope is 1/1, which is positive 1. Down 1, left 1, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. This has a slope of negative 1/1, which simplifies to, of course, negative 1. Now, when you look at it like this, they don't look like they're reciprocals of each other, but they actually are opposite reciprocals. The unique thing about the slope of 1 or negative 1 is that 1 is its own reciprocal. So these do intersect at 90-degree angles, as you can see. So this is the only unique case, is that 1 is its own reciprocal. So the opposite reciprocal of 1 is negative 1 and vice versa. Okay, so I'm going to put this up here, press pause, and copy it down, and that's the end of this video. You got one more to watch.